topic that is critical to the future of renewable energy integration, battery energy storage systems, or what we call as BESS. My name is Shivali Dwivedi, Energy Technology Specialist at the South Asia Regional Energy Partnership Program of the USAID, and I'll be your host for this session. It's a pleasure to have you all with us today as we delve into how BESS is becoming a crucial enabler for renewable energy integration in South Asia. The aim of the session is to provide us with deep insights into the role that BESS plays in renewable energy integration, helping us move towards a sustainable future. Our discussion will explore the benefits, challenges, and potential of BESS in driving the clean energy transition. Without further ado, I would now like to invite all the panelists and speakers of the session on the stage, beginning with Mr. Vivek Pandey, Senior General Manager at Grid India, who has been working proactively to ensure the operational stability of India's power grid. Mr. Vivek. Mr. Pratyush Sinha, Vice President of Special Projects at Loham Cleantech Private Limited, a critical materials company based out of India. Mr. Brajesh Kumar, Chief Project Development and Commercial Officer, IPP Business at Gensol Electric Vehicles Private Limited. Mr. Suhas Sutar, Vice President, ESS Business at RE+, who currently leads the stationary energy storage business at RE+. Now I would like to invite Mr. Adarsh Nagarajan, Principal Researcher and Group Manager at National Renewable Energy Laboratory, where he leads Advanced Power System Research at NREL. Mr. Alexander Rutter, who is the Electricity Sector Lead at Third Derivative RMI. And lastly, Mr. Vivek Bharadwaj, Objective Lead, Energy Storage and Green Hydrogen at SACEF program of the USAID. So thank you all to our distinguished speakers who bring a wealth of knowledge and experience in today's session. Thank you for being here today with us. Moving on to the next phase of the session, I would now like to invite Mr. Shankar Khagi, Energy Specialist, USAID Nepal, to deliver the welcome remarks and kick off today's session. He currently manages USAID's Urja Nepal program. Please join me in welcoming him.
Thank you, Shivali. It's a distinct pleasure this morning to welcome you all on behalf of USAID. And I'm very excited and I'm very glad to see that we have a room full this morning. It's a third day. And I am very much looking forward to learn from the distinguished speakers, and not only from the speakers, but also from the participants in the audience. And so I think we are all, we have some level of knowledge on this topic. And I don't think, we have, I think as we are trying to, move ahead with this technology, among many others, as we try to navigate how do we achieve and address the issues of climate change that's affecting the whole world, and we all have our NDCs, net zero emission targets, but what would be the role of battery energy storage among the host of other storage technologies? And battery energy storage is one of those technologies which is promising, which is picking up in many of the countries, particularly in US, China, and some other countries. But how is this progressing in the context of South Asia? What do we need to learn? What the South Asian countries are planning, how it is featuring in our planning, and what do we need to learn about the technology? How do we integrate it? How do we, regulate it? All these questions are some of the questions, we hope we will be able to get some insights into today as we try to hear from the distinguished speakers and I think we should try to raise some questions and try to learn collectively and see how we can plan, how Nepal should plan, how Bangladesh should plan, and India. So I think among the South Asian countries, India is already planning a lot of battery and storage technology. So we will hear about all these progresses and see what are additional questions that we would like to answer and discuss and take it forward. So as USAID's program in Nepal, as the Urja Nepal program that we are implementing in Nepal, we are also trying to help Nepal in terms of moving forward with some of the technologies, battery energy storage, and pumped hydro. India is moving a lot forward with pumped hydro technology. But in this session, we will be focusing mostly on the battery storage technology, how it has advanced, and if I look back, like a decade or two back, we are thinking that this technology will not be so we don't know how it will progress. But at this point, it's a very exciting technology. The costs are coming down, so we'll learn about all of that. And I'm very pleased that to see you all here. So welcome you again, once again, and so let's begin. Thank you.
Thank you, Mr. Shankar, for your welcome remarks. Before we delve into the opening presentation and the panel discussion, we also have launch of our report titled Demand Potential of Rooftop Solar with Storage, for which we have a short video with us. So I would request the IT team to play the video. Thank you. So as shown in the video, this report highlights that energy storage is a viable solution for both commercial and residential consumers at behind the meter level. For launching the report, I would now request our speakers to launch the report, and I would also like to invite Mr. Shankar and Ms. Monali to join us on stage for the report launch. Can we have a round of applause, please? Moving on to the next phase of the session, we have an opening presentation of the session, for which I would like to invite Mr. Alexander Rutter to provide us with an overview of the latest trends in BESS deployment, cost reductions, and international case studies. Over to you, Alex.
Thank you very much for the warm introduction. I should note I'm going to focus primarily on grid operations. It's not to imply that behind the meter is not also valuable, and we can discuss that a bit more in the panel. But yes, so I lead the electricity sector lead for Third Derivative. which is a subsidiary of RMI, and my remit is RTC power, long duration energy storage, and BESS as well. I've also led the work on BESS at IFC, and so this is something that's been I've been very passionate about for a long time. So the first thing I want to make the point is that I often hear BESS, it's emerging, it's new, it's the future. It is the present. Let me be very clear. So last year, 42 gigawatts of utility scale storage was installed globally. And just for context, there's about 14 gigawatts of hydro, about 9 gigawatts of nuclear. So when people say, oh, nuclear is an established technology and BESS is an emerging technology, I say, well, actually, there was 6 times as much BESS installed last year as nuclear. And this year, BESS actually should pass both coal and gas to become the #1 source of firm capacity globally installed. So I think that is important to note, is that this is not an emerging technology anymore. This is very much an established technology. This is another point, and it sounds kind of obvious, but I want to reemphasize the difference between capacity and energy, because we often measure things in terms of megawatts, and when it comes to wind and solar, as hopefully people know, the utilization factor of solar and wind is much lower, right? So you can't compare megawatt, 1 megawatt of solar is not worth 1 megawatt of coal. But storage is. So storage is a capacity-only resource. It doesn't produce any energy. You need the solar or the wind or the hydro to produce the energy. You're only providing that firming capacity. And so the way I like to think of it is storage is providing the fixed cost, whereas your wind and solar is providing the variable cost. So, in a lot of countries, like in India, you see coal has a fixed cost and a variable cost. This is the way I like to think about storage versus renewable energy. My biggest pet peeve is when people talk about the levelized cost of storage and they say rupees per kilowatt hour, because I say the rupees per kilowatt hour is infinite because it doesn't produce any energy at all. It is to provide firming, peak, reliable pakka power. So what exactly is a fixed charge for? So it's the ability to meet the peak demand. It's the ability to provide firm power. In many sense, energy storage is actually superior to coal. It has a much faster ramp rate. It has a much faster primary. So if coal wants to respond to frequency deviations, it actually takes several minutes, and there's a significant efficiency penalty. Battery can respond instantaneously. So if you have surplus solar during the day, which we're anticipating many countries will have surplus solar during the day, your coal plant has to turn off and on again, which is extremely expensive, whereas battery can reply almost instantaneously. Coal power requires diesel gensets, whereas battery can self-start. One thing often people talk about is inertia, and this is certainly an advantage of hydropower, for example. But even nowadays, if you're willing to pay a slight premium of about 1 to 3%, batteries with smart inverters can now provide inertia, synthetic inertia, and islanding mode, which is particularly relevant for mini grids, where you might actually have no diesel genset, no coal, no hydro, but you're just relying on the battery to provide the system frequency. So how much does storage cost? I think, so the first myth I've hopefully busted is that storage is new and emerging. The second myth is that storage is expensive, and I hear this a lot, and it's my second biggest pet peeve. So a lot of it is caused by the confusion of energy versus capacity. The correct way to measure storage is capacity, so lakh per megawatt year. So this is a recent SECI tender in India that came in at about 45 lakh per megawatt year. Now that was only 2-hour storage, but even a 4 or 6 hour is 75, 80, 90 lakh per megawatt year. This is Uttar Pradesh. These are the new coal plants that are being built in Uttar Pradesh. As you can see, we're talking 150, 200 lakhs per megawatt year. So energy storage is already about 1/3 the cost of new coal plants. I think this is the misperception people have. People say energy storage is expensive because if you have solar is super cheap. And when you add energy storage to firm the solar, of course it's more expensive. Solar plus storage is going to be more expensive than solar alone. But the question should be, what is cheaper, solar plus storage, or solar plus wind plus storage, or coal? And this is kind of the correct metric. The other way to look at it is to compare the baseload cost. So this is if you combine the solar and the wind, so the very cheap solar, very cheap wind, combined with the firming power of storage. And this is Maharashtra. So again, if you look at the recent coal plants that Maharashtra has contracted, the average price is about 7.4 rupees per kilowatt hour versus the blended price of storage with wind and solar is about 4 rupees per kilowatt hour. All India, we see FDRE tenders. I've got some issues with FDRE, which we can discuss on the panel, but even there, you see FDRE being substantially cheaper than the new coal plants. Now, the big question is what duration of storage is required. So one of the nice things about hydropower is that you can, I used to work for a hydro utility. We actually had a Lake Winnipeg was our reservoir, and you could literally put months of storage into Lake Winnipeg. And it depends a lot on where you are. So this is a sample of an Indian load profile. This is in Gujarat. And I think this is a 3-hour storage. The yellow is the battery discharging. And I think there's this perception that it's like, okay, the battery has to turn on at, say, 7 p.m., go for 3 hours, and turn off at 10 p.m. But realistically, if you think of the way a grid is operated, we've got lots of different resources. So this is just wind and solar. This isn't even accounting for hydro or thermal or anything. But the point here is, when your wind is high, so the wind is in blue, so let's say at 20 hours you've got lots of wind, your battery goes down. At 18 in this example, you've got less wind, so your battery goes up. And this is, I think, a key advantage that people don't appreciate about batteries versus coal. Coal can't do this. Coal can't ramp up and down to match the wind profile. But battery can. And that's one of the real values, I think, that is not currently appreciated by a lot of regulators, and I'm sure our friends at Grid India can speak to this as well, is that as wind varies up and down, we need to be able to kind of balance that variability. And that is what battery storage is particularly well suited for. So this is an example of Delhi's load profile. As you can see, their peak is during the day, but that should be covered by solar. We've got surplus solar during the yellow hours during the day. And so it's actually only about a 2 to 3 hour storage that's needed to meet that evening, that secondary peak in the evening. That's kind of that green bit there. Now, as we get higher and higher percentages of renewable energy, if you have no coal and no gas, then maybe you need 4, 5, 6 hours. But I think there's a misperception that we need 24 hours of storage. No, the point is we need to meet that peak. We have the solar during the day, you have the wind fluctuating, and then you need that battery to meet those key crucial hours. This is an example from NREL, which is saying, as the percentage of annual electricity from wind and solar goes up, then you start to need day, week, seasonal storage. But I mean, India's at 11%, so we're just beginning here. Top right, we've got some numbers from CEA, where they did some analysis that showed that BESS actually, basically 2-hour BESS is half as valuable as coal, and 6-hour BESS, or 6-hour PSP, actually has a higher capacity credit in coal. I think that's the impression people say, oh, it's only 6 hours. No, 6-hour storage is more firm than a coal plant. In UK, where you've got 40% VRE, they need 8.5 hour storage to be as firm as a coal or gas plant. So as you get more and more wind and solar, you're going to need longer duration storage. But given the level of penetration today, the 2, 3, 4, 5 hour storage is sufficient. This would be different than, say, a mini grid where you're off grid and you have no connection to hydro. Then you need longer storage. But I'm talking about grid duration storage here. There's 3 main ways to procure storage, and this is something I think South Asia's struggling with a little bit. How do we value storage? So resource planning is the approach taken in California and China, where you basically have a strong regulator that says, we want to make sure we meet our needs. We're going to ensure we have adequate. We're going to mandate that the utility procure sufficient volumes of firm capacity to meet our needs. Where I come from, we've got capacity markets, where they basically will have an energy market, so that's that real-time, rupees per kilowatt hour or taka per kilowatt hour. And then separately, you've got a capacity market that's kind of looking, say, 3 to 5 years ahead and says we need to procure firm capacity. And the key here is it should be technology neutral. You should say energy storage can participate, demand response can participate, gas can participate, hydro can participate, anybody can participate. Currently, in most countries in South Asia, you have a separate planning process. You have procurement of RE plus storage, and then you have procurement of coal. And again, one of the key takeaways should be you should be putting them on the same playing field, let them compete in competitive capacity auctions, as opposed to right now where they're separate. The other option, which I wouldn't recommend, but it is telling that this works, Texas is actually one of the highest penetration of battery storage, and it's purely an energy market. So in India, they've capped the energy market at 10, and now there is a high price, but it's not really liquid, and I don't want to get into that, but in Texas, the maximum price is $9,000 per megawatt hour. So basically, people will install storage on a purely market basis just to capture those handful of hours a year when they're really, really short. Given the concerns around energy access and price volatility, I wouldn't recommend this for South Asia, but I think it's illustrative that when someone says it's not economic, I say no. If you let the market decide, if you just let economics dictate, you actually get a lot of storage. And Texas is not an environmentally friendly jurisdiction. They're not doing this for climate reasons. They're not doing this for sustainability reasons. You see the BESS going in Texas purely based on market signals. So yeah, value stacking, and I'm certainly, got some folks here that can speak to the value of storage on the distribution side, on the transmission side, and we can talk about that as well. But I think fundamentally, if you look at the way the regulators handle it right now, they pay for fixed charges and they pay for variable charge. So to me, the simplest way to do it is just say, the battery storage can pay for the fixed charge. This is the three main approaches. One is the FDRE. One is procuring your solar and storage together. And then the final approach, which you see GeoVanel and SECI doing, is to procure vanilla standalone storage. Personally, I actually prefer the standalone model because if you trust your discom, and I've met the Grid India folks, I've been to their facility, not Grid India, Grid India in Delhi. These guys are smart. They know what they're doing. They know how to manage resources. And I've been to the dispatch centers in Karnataka and Gujarat and North India. They know how to dispatch. So to me, it makes sense to say, let's procure the storage as a firm capacity resource and let the discom procure. Okay, do I have time for this or should I just skip it? Okay, last few points, which are slightly tangential, but I know this comes up a lot. One is the energy security argument. So I know there's a lot of concerns, the energy storage. The packs are fairly easy to do, but the cells are fairly concentrated and imported. But here's an example from India where you look at the amount of gigawatt hours you get per crore of imports, and basically it's 15 to 1. So India spent $40 billion on coal imports last year versus $2 billion in battery imports. Even if the battery is imported, and I encourage manufacturing, and I know SARP and other organizations, people are talking about manufacturing, but even if it's 100% imported, there's still a massive security energy security benefit. The chart on the right, the blue is oil imports, the red is coal imports, the yellow and green are solar and battery storage imports. So when people say, oh no, we imported $2 billion worth of batteries, it sounds like a big number, but it's actually a really, really small number relative to how much you're saving in fossil fuel imports. Another one is jobs, and this is where rooftop solar really, really shines, pun intended. Coal creates a lot of jobs right now, but that's because coal produces so much of India and Bangladesh, for that matter's, energy. If we start building solar and wind, if it starts to become a significant percentage of the generation, then the jobs will come as well. And hydropower is actually quite job intensive as well. And finally, the last thing, I know this is a particularly touchy topic in India, where people say, oh, but what about the government revenues? They say, that there's kind of support for kind of local jobs and district mineral funds and this and that. But if you actually look at the government revenues as a percentage of the cost, it's actually higher for renewable energy than for coal. And now this is I think surprising to people. People say, oh, well, coal generates 70,000 crore per year in government revenues. But again, that's because coal generates 75% of India's electricity. If solar generated 75% of India's electricity, the government revenues would actually be higher. So again, it's important to put this in per unit terms, whether it's jobs, whether it's government revenues, or whether it's imports. I think it's really important to emphasize that battery storage as a firm source of power enable the solar and wind is better on these fronts than coal. That's all the presentation. I'm really looking forward to the discussion on the panel, but thank you so much for the invitation, and happy to follow up as required. Sure. I mean, if there's any questions, I'm happy to take them, or as part of the panel, or of course, you can find me afterward. It's fine. We can, yeah.
Yeah, so thank you, Alex, for sharing your experience and breaking various myths related to BESS for us. Now, we move on to a panel discussion. This panel will explore key challenges and opportunities in BESS implementation across the region. And the panel discussion will be moderated by Mr. Vivek Bharadwaj from SACEF of USAID. And I hand over now, Vivek, to you to moderate the session. And just a time check, we have 40 minutes for the panel discussion.
Yeah, thanks. And then we will have a round of Q&A too. So thanks, Alex, for setting the context, which clearly shows that the time for BESS is not in the future, it is already there. And purely if you look at economic reasons, then the levelized cost of storage or capacity charge for BESS is clearly much lower than thermal. And as Alex nicely put, if you put a thermal plant, it is going to cost you around 5 to 6 rupees per unit of electricity. While today, if you look at the current BESS prices, they are almost equal to the price of thermal, or in fact, even slightly less than the price of thermal. So nicely put, and I think the time is now. But in this panel discussion, we want to touch not just upon used cases, but we have panel discussions which are across the supply chain. We have manufacturers who are making battery packs for supplying utility grade as well as rooftop grade battery systems. And we already know that the prices have gone to less than $100 per kilowatt hours, which really makes this business case so viable. We have others who is even more integrated backwards towards critical minerals, towards lithium ion and other alternative of cells, and I think they have a line. But we start off with Vivek. So Vivek, can you kindly tell us about the background, a bit of background for our audience about what does Grid India do, and how are you planning to integrate BESS into your operations, please?
Yes, good morning. So thank you for that question, and it was a very, very interesting presentation setting the context. Grid India, as many of you would be knowing, Grid India is the national system operator, independent system operator, and we have 5 control centers in the region. So they are known as the regional load dispatch centers, and to coordinate the functions across these RLDCs, we have a national load dispatch center, which is responsible for integrated and stable operation of the entire country's grid, along with the cross-border exchanges that we have with our neighboring countries, Bhutan, Nepal, Bangladesh, Myanmar. So coming to the integration of BESS into the grid, yes, certainly as a part of our energy transition plan, there is a very ambitious target to add more and more of renewable energy into the grid, solar, wind primarily, to reduce our carbon footprint. So that is going on very aggressively, and in the last few years we have seen a massive addition, and going forward also there is a target of adding as high as 50 gigawatt per year for the next 3-4 years to achieve that 2030 target of 500 gigawatts. So certainly it introduces a lot of variability into the grid from the supply side, and considering these resources being weather dependent, and there are other challenges related to the climate because of climate change and other factors. We have been experiencing weather extremes, extreme heat, extended period, even last year. In fact, this winter, early in January, we had extended period of foggy weather for continuously for 31 days. Then even we have had extreme scenarios wherein we saw that during the high RE season in August itself, we had a period of continuous 10 days wherein we experienced, August is supposed to be a high wind generation period, but we had an extended period of 10 days or something where the wind generation was as low as 5,000 megawatt. And then suddenly in the last week of August, it shot up and went up to as high as 20 gigawatts. So in August, we saw several days, particularly during the weekends, and we had several holidays also coinciding with those weekends. So we had really a tough time. We experienced high frequency operations for a prolonged duration, and during the day we found that our down reserves, the legroom available in our thermal capacity had completely exhausted, and because we have to meet the non-solar peak also, so it was difficult to pull out those thermal units off bar because we have that non-solar hour peak in front of us. So that created a very big challenge. So these challenges are going to further increase, certainly, for sure. And that is where we see great utility of storage technology, whether it's from the pump storage or whether it's from the battery energy storage. So for us, the big application would be one in terms of energy shifting applications, and second, certainly in balancing, minute-to-minute balancing of the variable generation, certainly. Then the other thing was regarding the transmission, as it was highlighted in the presentation also. Because of our skewed disposition of these renewable resources, we have to build those transmissions from, say, from Rajasthan complex or from Gujarat Khavda complex to our load centers. Now, this solar capacity, of course, the CUF is pretty low. So if we have a battery co-located with these RE plants, then certainly it helps in optimizing the transmission requirements. It helps in firming up the utilization of our transmission system, so which in turn helps in better voltage regulation and improves the stability of the grid, and also helps in congestion management. So a lot of applications that we look forward in BESS, certainly. So it's
Okay, yeah, so we'll come back to more questions on the second round. I think part of this enabling a low pricing of BESS is credited directly to equipment suppliers and the supply chain revolution which has happened. For this, I would request Pratyush, Mr. Brajesh and Suhas on a brief background on what is it that you are doing in the BESS supply chain, and generally to talk about what is happening on the equipment side and especially the battery prices which is enabling this BESS revolution. Thank you.
Hey, hi, I'm Pratyush. I represent a company called Loham. We are a lithium-ion battery recycler and refurbisher, and we make raw materials for batteries as well. With respect to BESS, we've been involved in this industry for almost, I think, 5 years now. We've been putting out second life battery packs, repurposing batteries that have come out of EVs, but also from telecom towers and even ESS applications into second life applications. In terms of how we look at BESS for solar or for grid applications, we did some analysis on the IEX data recently. So we looked at the entire data for last year, and we saw that the average difference delta between the max and min rate for electricity is around 6.75 rupees a kilowatt hour, and the peak is somewhere around 9.5. So almost 0.5 rupees is what you get at the lowest cost. So what this seems to us that there is a very clear arbitrage opportunity, if not anything else, for BESS. And so that's one thing that sort of gives a clear indication that there will be a storage requirement. The second thing that we know is that all of these batteries are going to reach their end of life at some point of time, and they will need to be taken care of. Or even EV batteries, there's almost 128 gigawatt hours of batteries that are expected to come back by 2030 as per Niti Aayog's estimation. And not all of these batteries will be dead. A lot of these batteries will have life left in them. So they'll need to be put somewhere. And that essentially what drives us to work on this, to essentially ensure that these batteries find a home. And considering the economic opportunity that BESS provides, it seems like the right place to put these batteries in. So I'll stop now and we'll probably take up more questions later.
Hi, good morning. My name is Brajesh and I represent a company called Gensol. And within Gensol, we do have a few verticals or the group companies which caters to energy solutions in solar segments. And also we have e-mobility space under the brand of Blue Smart and Anvi. And then we also have a gas business under the brand name of Matrix Gas. Our story in EV space is started with electric vehicles. So if you are from Delhi or Bangalore, I'm sure you would have seen Blue Smart cars. So that's a fleet owned by Gensol Group. And then behind this fleet, we also have a smart charge infrastructures. We do have several hubs. So that's what we cater to our own fleets. And also we have launched few services where we are catering to the customers for the last mile connectivity as a part of Let's EV Go or for the passenger vehicles leasing to the corporates as well. So that's what we started with. But where we want to be is looking at how we can deploy and scale up battery applications in the grid size applications. That's where we participated in few tenders, and we were could say that we were among the first ones who led to this sharp decline in the tariffs in India. So Gensol won 2 tenders, which was auctioned by Juvenile early this year. And the tariffs that we were seeing were pretty much half of that was seen tender which was auctioned a year before, or a few months before. We plan to continue in this journey, and what we plan to do is to set up our own manufacturing line as well. And this will help us to cater to our internal requirements, given that we will have a huge EV fleets. And also we will catering to the external markets from the developer side as well as EPC side. Our experience so far has been, I would say that coming from Blue Smart EV vehicles, and a lot on the safety side, on the efficiency side, and that we would like to leverage going forward as we scale our operations. Yeah.
Hello all, I am Suhas and I represent RE Plus NG Tech Private Limited. We are cell-to-pack manufacturers for lithium-ion battery and having facility of 1 gigawatt hour in India. Now coming to the question, from manufacturer's perspective, if I have to talk, what I foresee is, or what I see is currently the prices are down, but they are artificially down, because if you track all raw materials or all ingredients required for manufacturing of cell, they are maybe they are stable, they are not increasing the way lithium carbonate was shot up or other minerals were shot in previous 1 year, but currently they are stable, so there is no reason for these prices to go down. So what I see is the price reduction is an artificial phenomena because of demand supply gap, and that creates a lot of pressure on local manufacturers, because though we are manufacturers, still the majority of raw material is coming from China, because that kind of ecosystem is not really available in India. So even if we are assembling packs from cell, so cell itself is coming from China, and when you go to and buy for cells are not at that reduced, like the relation in cell price is not proportionate to the containerized solution which you get from outside India. So that pushes local manufacturers to the to difficult situation. Secondly, when we are like government announced PLI scheme for cell manufacturing, but I think similar scheme should be applied to the rest of the ecosystem, which will enable the battery manufacturing to be more competitive with respect to what is being available in India from outside of India. And then the other point I wanted to talk was about this the pricing which is being offered right now or available to the IPPs. Because as a manufacturer, I don't have that burden of taxation, because ultimately the taxation is passed on to the developers. So if you look at the GST component of it, so since solar is renewable, there is a concessional GST for solar. But now when we are talking of like solar plus BSS is making viable case, but then BSS is treated as separate matter in GST, and then there is a very high GST, and which is ultimately causing it, this is like going as a burden to the developer, and then that is repercutating into the levelized cost of storage or the capacity charges. So I think from that perspective, the taxation and duty structure also needs to be relooked into by government, so that it makes even more feasible for the Indian grid. And the other part on pricing was, currently, though we were looking at like thermal prices are going, like thermal purchase price is 7 rupees or something, but when you look at from DISCOM perspective, the average power purchase price of DISCOM is still 4.5 rupees or 5 rupees, looking at the non-peak hour energy rates which are available in the grid. So when solar plus BSS or any renewable source plus BSS is being put forward to compete with, or is being compared with that APPC, it is still becoming kind of unviable thing for the DISCOMs. And I think that's why government had to bring into that VGF kind of thing, which will make sure the blended price, energy price of solar on BSS or wind and BSS would be comparable or would be acceptable to the local DISCOMs. Otherwise, I think the challenges which we faced initially during this BSS business, the tenders were awarded, but then the nodal agencies were not getting buyers for purchase of this high rate energy, like or the stored energy, which is costing like solar plus cost of storage, which was going more than 6 rupees, and then there were no buyers to take that energy from the DISCOM side.
Thanks for those insights about the GST benefits which could reduce the price. My next question is with Adarsh, who comes from a unique experience from the US. And in the battery system, we forget that one very key component is the hybrid inverter. Without a hybrid inverter, there is no battery. Battery is just a DC device, and ultimately an hybrid inverter is the one that takes a PV input, solar input, it takes a battery input, and then it combines both of them to give energy to the load. So Adarsh, it is requested to get your experience in the US and especially talk about the role of hybrid inverter and its functionalities into giving seamless use cases for battery in the grid.
Thank you. This is an esteemed panel. The points of view we are hearing is quite unique and very insightful. So at the lab that I work in, it's the Department of Energy's lab, I get to interact with various stakeholders across the supply chain. The excitement on one end, the challenges on the other end, and the regulations on the third side makes all of this quite interesting. As the moderator so rightly mentioned, the value of storage is enabled by a technology called inverter. Most of the renewable energy technologies cannot generate a fixed 60 hertz or a 50 hertz frequency that a consumer needs at the end of the plug point that we plug in to charge our phones or computers. A need for an inverter is a fundamental need, and the costs of inverters have more or less saturated. It's no more anticipated to go down any further. If anything, due to supply chain restrictions, it may even rise, impossible to guess. As the moderator pointed out, the need for combining a renewable energy technology along with a battery can be done two ways. Either each technology there get its own inverter, solar or wind gets its own space, storage get its own inverter. That's referred to as AC coupled. They're coupled at the frequency level, and both are following that integrates to the grid. Or you can have one inverter at a bit of a larger capacity, and both technologies are connected at the DC or non-AC level, called DC coupled inverters, and that's what hybrid is referred to by Vivek. Both exist, both are viable, particularly when solar interconnected DC coupled is very viable. When coupled with wind generation, DC coupled is not viable, it has to be separate. The challenges that go either ways are cost benefits versus not. If you DC couple, there is one technology, so there's a natural cost saving, particularly when it comes to residential. I was looking at the report, thanks to SACEF for creating this. For residential end use, a DC coupled is a very viable option. It brings cost savings. You don't have two inverters, you can have one inverter. There's a cost saving that happening there. And also that forces the battery to charge from the solar panel, and it's not going to become a load to the grid during peak times. It's a natural benefit that comes, which we need to leverage at residential, commercial, or behind the meter assets. When it's a standalone, like Alex mentioned, the vanilla standalone energy storage, it has to be separate inverter, and it has to charge from the grid. There is no other way around it. So all technologies very well exist. All of them have its own advantages and disadvantages. We have done good public reports on that. I can talk more about it. But for now, I'm going to pause and see what other questions do we have. Thank you.
So yeah, I mean, just to take this to the next round and asking a very quick question to both Vivek and Alex. Where do you think is the best location to put a battery storage plant? Should it be on a substation level, or which is basically close to a load, or should it be at a large ISTS high voltage which is further away? I mean, please, quick comments, please.
I can start. So firstly, we shouldn't spend 5 years studying it. I think, right now we're in Rajasthan. The APPC may be 4.5, but the new coal plants, Chabra, Kalsin going up, are 7 rupees a kilowatt hour. And so, if an FDRE is 4.2 and a coal is 7, we should be just deploying it anywhere. That said, obviously there's advantages to both. If you put on the generation end, particularly, as we heard from Good India, for the Rajasthan and Gujarat case, where you have massive solar and wind parks, basically instead of building 30 gigawatts of solar and 30 gigawatts of transmission, you can build 30 gigawatts of solar, 15 gigawatts of storage, and 15 gigawatts of transmission. So for that use case, I think the transmission, the generation end, and as Adarsh mentioned, putting on the DC coupled could potentially have even more cost savings. At the same time, particularly in India and many countries in South Asia, you've got these very long distribution feeders. And so you often have high outage rates, you have very low reliability, you have very high cost to get that kind of last mile. And so in that case, if I put the storage, let's say at the farmer's end, on the, I've got a solar pump that can inject back into the grid, and then I can put the storage there, and I can actually defer my distribution transformer upgrades. So, it would be dependent very much on a case-by-case basis, on a discount-by-discount basis, but there's certainly merit to both.
Vivek, can we have your similar comments on what is the best location to put a battery? I mean, is it on the load end, or you have any specific advice for where exactly to put the battery?
Yeah, I pretty agree with what Alex is saying. It has to be worked out, actually, the use case. So in our scenario, if you look at the high concentration of RE generation in certain places, so obviously the loads are not there in the vicinity. So we have to build up huge transmission to evacuate that generated power and carry it to the load centers. So certainly it makes sense to co-locate the battery at that location and then work out the optimal transmission requirement. Then similar thing, if you look at placing BESS at the consumer's end. So for example, large C&I consumers, there are discussions going on to place batteries there. If you place a battery there, then obviously a battery has to be charged from a remote location, a solar plant or a wind hydro plant located far away. So that does not help you in reducing the transmission requirement. Anyway, transmission has to be created. So if application is such a kind, then certainly you have to look at the investment that is required in transmission and do the optimization. There is another perspective that is important here when we look at the resilience. For instance, if there are areas which are very vulnerable to extreme weather events, for example, coastal areas or those places. So they are quite vulnerable, and there are chances that due to extreme cyclone or whatever, we have an impending cyclone also now. So under that situation, if we lose the transmission, then it's very important that we have some amount of storage locally that helps in enhancing your resilience and help you in surviving. It's just like having an inverters in our homes. So it helps us in surviving for a few hours till the supply gets restored. So it again, we have to think the kind of application that is. So that will determine the where we have to place the battery.
Okay, yeah, thanks for those comments, very valuable. Pratyush, we have a lot of our stakeholders coming from different places in South Asia, and they have massive deployments of EVs in the last mile deployment. What is your message to them to do with those lithium-ion cells or those stacks by the end of their life? What is your message to them? Should they have a recycling program? What exactly to do with those battery cells?
Good question. So I think the first thing that needs to be done is at the end of life, you need to ascertain whether the battery is reusable or not. To do that, there is requirement for some data and for some inspection. Data requires there to be a data infrastructure. So OEMs have to collect the data, and that data then needs to be shared with refurbishers. Unfortunately, a lot of OEMs, at least in the past, did not have that infrastructure. So what that entails is you require testing of batteries. So you'll need to have testing centers, and that is where some of the local authorities or government can intervene, because there is a requirement for certain safety standards for handling these batteries. EV batteries in particular can be very high voltage and also can store a lot of energy at one place. So that is there. And once you have the batteries and there's testing, some sort of testing infra, you determine whether the batteries are reusable or not. If they are reusable, then the batteries should be handed over to the relevant refurbishers, or the relevant refurbishers can themselves set up these decentralized testing units. If the batteries are not reusable, then the batteries need to go into recycling, where they are essentially processed first mechanically and then chemically to take lithium, nickel, cobalt, etc. out. Depending on the chemistry, if it's LFP, you take the lithium out, or in some cases the LFP molecule out. What we've also been trying to do is produce the cathode active material. So we are setting up around 20 gigawatt hours of cathode production capacity. So the gigafactories that are coming up, as Gensol also is planning to do, will require cathode, and one of the key cost drivers of batteries is the cathode. And one of the reasons China has been able to produce batteries at very low cost is because of the vertical integration that helps them get from mine to cathode to cell in a vertically integrated manner, such that you essentially the same company can produce everything, or at least these things are produced in a co-located manner in a lot of cases. So that is what we are trying to do over here, set up that capacity in India. And yeah, so then the idea is, if it is recyclable, let's get there. If it's to be refurbished, there needs to be some standards. So in India, for example, BIS is working on standards, couple of standards. First is on data sharing standards between producers and refurbishers, and the second is standards around testing of batteries before putting them out in second life. There are certain standards for BESS batteries, although I would say that more needs to be done on that front as well, but there should be some additional standards around second life batteries. So I think Governments can play an active role there as well. And then you can put the batteries out in the field.
Okay, thank you. And I think that matter is especially important because you have a lot of data centers which are coming in South Asia, especially in areas of Bhutan, what we have heard. And I think a lot of these second life batteries have a huge potential for deployment at data centers, having been used in a EV vehicle, which can be combined with solar to power up data centers, because there is a huge pressure on them to have green data centers and not just put on thermal. So I think second life is clearly a very, very important application of using these batteries, which have maybe 50% of the capacity remaining with them. Yeah. Brajesh, I think Gensol has clearly been a pioneer making waves in India for battery developments. What is the tenure of these PPAs, if I can call them, that you have with DISCOMs? What is the expectation? How many years? I mean, what are the broad terms at which you are signing these agreements? Perhaps you can help our audience understand the broad contours of those agreements. Yeah.
Sure, Vivek, thanks. So we have two projects under development at this point of time. These are with Juvenile, utility based in Gujarat. So under the terms of, there's no, instead of PPA, it is called BESPA, a Battery Energy Service Purchase Agreement. And as we discussed, it's a capacity-based agreement, so therefore recovery of revenue is in the form of rupees per lakh per month. So that's what we will be doing. And this period is for 12 years. It's not 25 years, so 12 years. Land and evacuation point is specified by the utility. So we have to set up within one of the grid substations which are already up and running. So that's what we have to do. They have already identified 3 substations for our project. So at one location, we are setting up 70 megawatt / 140 megawatt hours somewhere in Kutch region. Then we have another 500 megawatt / 1000 megawatt hours, again is split into 2 parts, 250 megawatt each. One project is closer to Ahmedabad, and other project is in Saurashtra region in Amreli district. At this point of time, what we have done, we have done some tie-up with the technology suppliers, given that though we ourselves are setting up the battery manufacturing, but that will take at least a year, and some certification will take at least some more time. Under this agreement, we have to get the project up and running within 18 months time period. Working backward, the first step was to complete signing of the agreements with the utility that we have completed, at least for the first project. Second project is in progress. For doing the feasibility work, that as both the locations are going on, and one of the key challenge or the key important aspect is integration. So my technical specifications of my AC side of the plant should match with the AC side of the equipment which are already up and running. And in some cases, some of these equipments is already quite old. So we have to make sure there is a seamless integration. And also there has to be data visibility, which is like a SCADA system connected with the utility network as well as my own network. So data transfer is another element that we are working on with the utility. We have already signed, at least backward side, we have already signed the battery supply agreements with the suppliers in China. And hopefully, if all goes fine, then Q1 will be the groundbreaking for both these projects. So that's where we are. At the same time, if you see, just the battery prices have gone down. There have been a lot of tenders which are coming in the form of rupees per unit, where government is expecting people to do solar plus BESS together. And those projects are 25 years. And we are also participating in these kind of projects, and which will require at least one refurbishment and the replacement in between the time period. So that's going to be a tricky part of how overall things will work. We are still working on the solutions.
Okay, thank you. And so as on the same lines, the penultimate question, you come from a battery manufacturer perspective, and there must be an immense pressure on you for price. How to make sure these batteries work for 12 years? I mean, what are the quality inspection plans? What is the sort of inline inspection to do for batteries to last 12 years? I mean, is it just going to be the cost at the end of the day, or what is your opinion to the audience to buy quality batteries, so as to say? I mean, even though the discoms have extremely strict standards on LDs and all from their tenders, how to still make sure that they buy good batteries?
So when it comes to manufacturing, as I earlier said, cell is still an imported stuff and which is the heart of battery. So when we buy battery, we have to see what kind of cells are being used into, because the rest of the system, BMS is an electronic part which can last, like if you design it for industrial grade, it will last for 20 years. That's not a challenge. It's about the battery, a cell giving that cycle life and then that the energy capacity which is required as per tender. So getting good, so it starts with the raw material quality check at the cell facility itself. Like from there, if you get grade A cells, because in market if you go, there would be 3 grade cells available, and if means you may get a cheaper deal, but then you never know what grade the cells are. So ensuring that you are getting grade A cells, and what does that mean? That the cells which are manufactured are fresh, because many a times the inventory which is like 6 months old or 1 year old, the cell, the lithium-ion battery itself has an inherent characteristics of degrading on its own if it is not maintained well. So if you are getting a cheaper deal, it might be a 6-month-old stock or 1-year-old stock. So getting right ingredient for making pack will ensure the battery life or battery performance. And secondly, in-process inspection while manufacturing is also important. So in fact, at our factory, we maintain all records of right from every cell, and that goes into a manufacturing data management system where we keep record of each and every cell, which cell has been gone into. So basically traceability of each and every component of the battery pack, which along with the in-process test data, and that helps us to create products which are consistent in quality in each. So each module is of same quality, or each rack is of same quality. So I think that inherent quality management systems and good quality of raw material ingredients would make sure the required life is being met.
Thank you. And Adarsh, the last question to you. Can you talk about quality management systems of cells?
When you say quality, yeah, Suhas answered it so well. I have very less to add on top of that. Yeah, when we get batteries in our lab space as well for R&D as well, we do realize so many times some cells do not operate at the level, and we send them back and we get them new, and we hear reasons like it was sitting in the port for 3 months and it degraded, or we hear that so many times. It was a very common problem during COVID. All the battery cells we received after waiting in the port for more than 6 months, it did made a huge problem for our projects and deadlines. One angle I want to add is to all the manufacturer and experts on this dais and everybody else in the room here is we like to bring the angle of, when we say battery energy, we commonly think it's lithium ion. That's true, but it's not fully true as well. Battery can be more than lithium ion. We are actively working with the Central Electrochemical Research Institute, SECRI, planning to make a pilot on a sodium ion technology that's viable, why am I saying sodium ion? Is it's still battery, and also to some extent the manufacturing and scaling capabilities that's so well developed in India can be expanded to sodium ion. It's not as straightforward as you replace lithium with sodium. That's not, no way I'm meaning that. There's so much R&D that goes behind that, but it's wise for all of us to consider how to expand beyond lithium ion. I like the way Suhas so wisely put it. Right now it is stable, doesn't mean it's gonna be the same for long, or we have no way to predict the future. Expanding our horizons to beyond lithium will be very important, and the push for affordability is increasingly happening around the world. We want low-cost electricity, clean electricity all around the world, and that further needs us to think beyond lithium ion only as battery, to consider beyond lithium ion. I just want to mention that. Thank you.
Okay, thank you. And I think
Can I add something?
Yeah, please.
Yeah. So as you were saying, lithium ion is not the only solution, and I do agree to that. There are a number of storage technologies available, commercially available or under development all over the world. I think there are few parameters which one should consider while selecting a battery, because every battery has unique characteristics and it fits for particular application. If I have to give you an example of lithium ion, it suits for 4 hours backup or at the max 6-hour backup. 6 is also actually a stretch for a lithium ion battery. If you want to go for beyond 6 hours backup, then there are different storage technologies available. But further, all these, whatever battery technologies are available, energy density, power density, and the round trip efficiency, which is the most ignored part in while selection of the battery, because even the most efficient battery, which is lithium ion, which has round trip efficiency of 80% if I also count the auxiliary consumption of battery. So the most efficient is at 80%. So when you select battery, you will have to factor in those, because that indirectly impacts your levelized cost of storage.
Absolutely, and you could always increase it by liquid cooling, like what Tesla does in the US, in the home-based Tesla, which will have even a better RTC. But with this, we would like to really, set it open to the floor and request questions that you have, and I'm sure you must be having many for this session for our panelists to answer.
My question is a little wide spectrum in terms of what Alex has presented, that we must change everything to the battery. See, the coal, the kind of climate changes we are seeing, and the kind of climate behavior is happening, we have fogs for 30 days, we have droughts of wind, we have droughts of sun, we have many areas have different situations. In month of May, April, suddenly the power requirement goes so high. And that is the time, that is where these batteries, or which this is long duration things, are not able to support. And for that very region, whatever the coal has got negative things, the coal becomes the savior, because the grid is the one. In fact, the other day, Director Porwal yesterday was talking to me about that in month of August, we wanted flexibility, and flexibility was not available because of everything in peaks were there. So these are the instances where solution is still yet to come. So that is where I would like to make a bit one. And then what Sutar has mentioning, it's very, very alarming that the kind of demand is growing so widely, and that sources, the raw material sources are limited at sites, and that is the geopolitical situation is very, very fluid, very fluid today. You are able to sit only today with China, because there was yesterday that the solution has came. So that is where the things are happening. And what I'd like to mention that today is a time when everybody has a space. Everything has a space. I mean, we need to have the batteries, no doubt about it, short term, long term, whatever duration. But we need to have the long term solutions also, long duration solutions also, which will come with the conventional things. So that is where I'm saying. And I think the answer is still, it's not that simple as being presented here. That's what I'd like to make a comment. And if anybody like to respond on this, welcome to it. Thank you.
That's so true. That's so very wise. It clearly shows your experience and your vision that you brought up. I'm going to quickly answer that. Currently, we as a US National Lab System are conducting a long duration energy storage potential in India currently. We are helping Ministry of New and Renewable Energy, MNRE, understand what should be the cost targets for LDES. The moment you go long duration, the costs to make it viable will be scary low. It needs to be so cheap, it's very hard to make it happen. And also the energy density aspect that Suhas so wisely mentioned is very hard to make it happen. We need to have long-term vision, and seasonal storage, multi-day storage is going to be important, and lithium-ion may not be able to cut it due to its capital needs. And we are currently working with MNRE to make a vision report on that. We will hopefully able to break some progress on that.
I'd just like to add, so firstly, that NRL chart I shared with the percentage of renewable energy penetration to the duration, I think that's very important. Right now, India's at 11% solar and wind. For now, you mentioned this issue in August. The problem was coal, right? The wind, we had 40 gigawatts of coal on 150 gigawatts of load. So it's not like we had too much wind. The issue is that the coal couldn't back down, right? The coal is the one that's inflexible. The coal is the one that's the problem here. A lot of people say, oh, the wind is causing the problem, the solar is causing the problem. California, that chart never got added, but I added a slide last minute. California has 50 gigawatts of load and 60 gigawatts of solar. That's where they need longer duration storage. South Australia has 10 gigawatts of load and 10 gigawatts of storage. So the issue here is not that there is too much wind. The issue is that there is too much coal. Battery, 2 to 3, 4 hour battery will solve that. That said, I'm also leading our work at LDES in the long term. If we want to be net zero 2040-70, if we want to get rid of coal completely by 2047, absolutely we'll need LDES. Our portfolio, we've actually got a number of LDES companies, Antora, Energy Dome, Off-Grid Energy Labs, which is a zinc gel battery-based company here in India. So 100% we should be planning for the future and thinking about LDES and thinking about how to retire coal in the medium term. But my point about the 2 hour, 3 hour, 4 hour being sufficient, that's the short term. I'm talking about last week, Merck approved a new coal plant at 5.5 rupees per kilowatt. Last week, NTPC approved this new NTP SIPET plant, even though they were far, far more expensive than battery.
Yeah, I would just like to add on to what Alexander is saying. And I think what Alexander is saying, Indian Grid has already taken steps towards that, though we have huge coal capacity, but you should see at the CF at which they are operating. They are operating less than 60% CFN, which is very low for a coal-fired thermal plant. And I think that might be the reason for which coal prices are going up, because you are setting up capacity of, say, X, and then you're operating it at 0.6x, less than 0.6x, and that's pushing the coal energy prices up.
Thank you. Should we have another question?
So again, very nice discussion, so thanks for that. So a couple of points regarding, Alex, your presentation. You mentioned synthetic inertia and black start as other capabilities that battery storage provides. So is it equivalent to the natural inertia that synchronous machines provide today, or are there issues that still need to be sorted out on synthetic inertia in particular?
Yeah, I think, again, I'm not saying we should get rid of all inertial generation tomorrow. But yeah, you look at these islands like Graciosa Island, Tonga, where they're doing it completely on storage. South Australia has been kind of gradually saying, okay, we had 4 gas plants. Okay, let's go to 3. Okay, things have been fine. Let's go to 2. Okay, things have been fine. Let's go to 1. So, UK just closed their last coal plant. UK, there's a startup, the name escapes right now, but they're actually tracking inertia in real time. So there are technological solutions here. They do come at a cost premium, but again, it's 1 to 3%. We're not talking a huge premium, but you have to have the grid code that mandates it. But yeah, the short answer is yes. The short answer is yes. We've seen all around the world, synthetic inertia can replace spinning machines. The long answer is much more complicated. We need to study it on a case-by-case basis.
So if yeah.
Just the storage alone doesn't give inertia. Let's be clear. It's the inverter and not the existing inverter. It's a grid forming inverter. Let's be very clear. We just not go with putting storage, solar, wind cannot. Vivek, I can clearly answer that question more than anybody. He has seen that, I'm sure, 100 times a year, how inertia is getting a problem. Yeah, it's a technology evolution that should make battery viable for synthetic inertia. That's the controller inside the inverter, not even just the inverter. Controller development that's happening around the world. I think in the next 2 to 3 years, it's going to be off the shelf available, standards will be developed. That's the time frame where storage should be fully able to provide synthetic inertia, almost to the extent synchronous machines will not be even thought about. Not there yet. Let's be clear about that.
Yeah.
I think Vivek has
Just a small additional perspective to the discussion that's going on. See, we are talking about why battery is not coming up and why we are still going to coal, all that. So again, it depends on, for battery, as Adarsh was mentioning, still standards are yet to evolve in other countries, in India as well. Even so, when we have those standards and when we have manufacturing according to the standards, only then we might get the true cost of those capabilities that we are trying to look for in terms of flexibility or inertia or ancillary service or energy shifting, all that. So right now it's just some product and they claim that yes, it's capable of delivering all that. But when we really specify into the standards, then the real cost comes. We have our experience with inverters in India, and a lot of services which are there mentioned in the standards still facing extreme challenges to really enforce compliances. And there are petitions going on saying that it's a change of law and all those things. So the true cost only emerges when we have those standards in place and people are forced complying to those standards.
In fact, standard making is a long process, and it should be long process because there are a lot of stakes, there are a lot of dimensions involved. Safety is one of them, one, cost, economics, and many dimensions are involved because we are involved in many standard making. It's not that that if I demand, I mean, I need the battery tomorrow immediately, then it's standard, because you have to be time tested also. And so many things, sometimes, I mean, and also be ready to change because of IC, either whether it's IC or whether it's ISO or BIS, all things, they take time. So it is not that fast as we expect. So if it's without a standard, things may not be in the right perspective. See, there is no competition with the solar and wind as such. I mean, solar wind is more than welcome, and that's why I think all of us are working together. But my only question is, alert is only that don't depend on one technology. This is not a time era where you have to sync yourself everything with marriage. It says that marrying with the, when one is spouse, no. You have to, power is something which has to be a multi technology. Today, that is the scenario is coming. So that's where I'm trying to say that. Thank you.
Yes, certainly. The diversity of various technological options certainly makes big sense, but in countries like us.
So I'll just add another dimension to this, probably not discussed, but I think should be brought up, is that around cybersecurity. So if considering batteries are essentially going to be systems that are hardware plus software, and these are and the grid is going to rely more and more on batteries, this becomes an important aspect, especially the communication layer. And I think Sir mentioned that there are geopolitical concerns involved as well. And considering we are dependent on battery, the cell supply, at least on other countries, I think it becomes important that there are standards around cybersecurity for this. And there are, at least the communication layer should be either developed in India or in friendly jurisdictions. I think there are other countries that are working on it, and probably that's something that needs to be looked into.
Yeah, so with this, I think we should close the panel discussion because we are already running ahead of time. And to your point, Mr. Pratyush, like on cybersecurity, we have a session that is just following and going to start at 11:30. And with this, I would like to thank all the panelists for sharing their insights on this crucial topic. And telling us more about the technical and practical aspects of BESS deployment. With this, I would now like to invite Ms. Monali Zia Hazra, Senior Regional Energy Specialist and Mission Environment Officer at USAID's Indo-Pacific Office, to deliver the closing remarks. Over to you, Monali.
Thank you so much, Shivali, and what a really interesting discussions, and thank you so much to all our speakers, panelists, and presenter today. Excellent presentation, Alex, and also a very interesting discussion, not only on battery emerging, as Alex pointed out. It's not a new technology already established, but there are still few things which need to be addressed in order to have a full-scale deployment, even as we have examples of which our colleague from Gensol and RE Plus were mentioning. So, the key takeaways for me, at least from this session, was that, though BESS is, now popular, gradually coming up, it still needs supporting environment, taxation, duties for BESS manufacturing. Okay. It still needs, supporting environment in form of taxation, duties, standards, which was highlighted, still needs to be developed. That's an area which we would, as you said, would be looking at. In terms of, battery energy, while Loham, Pratyush mentioned about recycling and reuse, that I think is going to be one of the challenges which we should be thinking about and trying to address. Specifically, we talk about it, but you pointing out the need for infrastructure, data, as well as regulatory framework needs to be brought in. Looking beyond just lithium, iron, and to looking at other solutions, other technologies, pushing for affordability, as our Adarsh and our speaker from RE Plus were mentioning, are something which is very, very important. And then overall, with battery, there are challenges with raw material, looking at supply chain, and therefore having a longer term vision is very important. Having said that, we all agree that this is a technology which is really critical for India, along with many other technologies, to really, achieve India's targets of 500 gigawatt of renewable energy and overall getting into the net zero target by 2070. So with that, really interesting discussion. We would like to carry on, follow through with many of the speakers today to take some of these key action items into implementation, and also thanking all the participants who have been listening very carefully. We hope that you find the discussion insightful. Before wrapping up, I would like to, also thank our colleagues from SAREP as well as APP team who have put the session together, and thank you once again to our speakers and moderator. Thank you, bye.